that.
Yeah.
So basically, you've got your parentheses or your grouping symbol. You've got your exponents, right? And then multiplication and division, I like to put parentheses around that because they're equal in terms of when you're working left to right, okay? You don't do multiplication before division. Does that make sense what I'm saying? They're treated equally. Same thing for addition and subtraction, okay? Just working from left to right. And this kind of spells it out, right? Evaluate the expressions inside the grouping symbols. So that includes brackets, parentheses, even like a fraction line, right? Like 2 plus 3 over 5. There we go. You've got to add the 2 plus 3. So a fraction line counts as a grouping symbol. You do combine the numerator, combine the denominator, and then you can simplify it. Evaluate all the powers, multiply and or divide from left to right. That's what I was just saying. Add and or subtract from left to right. Okay, we got this. No calculator. Right? We can do this. This is like... Oh, it's because when I save things as a PDF... Yeah, you have parentheses. The parentheses are supposed to be there. Just let me know if my parentheses disappeared. It's one of those weird glitches when I save from a Word document to a PDF. Okay, so we want to evaluate. So we got 12, right? So let's go ahead. 3 minus -1 squared. So first thing we're going to do is, right, plug in the values. Look good? Right? Good? I just made it into a plus. Did you get it, Max?
Yeah,
28. 28? 28. Good. So now I want to see a little bit of work. When I say evaluate, I want to see, show me that you plugged it in correctly. A lot of this I know you can do in your heads, and that's fine. Like if you add that 4 and square it, that's fine. That's perfect. Okay. Next one I think is even easier, right? 14.
She fast. Yeah, I love 14.
Uh-oh. Uh-oh, Cece. It's okay. Don't worry.
Oh, yeah, that's definitely me. Why not?
So 2 times -1 plus 4. Yeah, and in fact, right, 12 minus 2, so that'll be 10 plus 4, 14. Good. Okay, evaluate the following expression. Oh, we got a decimal there. H equals 4, J is -1, K is 0.5. Here's what I would recommend. Okay, so J is -1 squared minus 3 times 4 squared. Now, instead of 0.5, I'm going to write that as a half. It really makes absolutely no difference. It's just, I see that I have an even number I'm multiplying it to. So sometimes it's easier, right, if you have an even number to multiply it by a half. And then in the denominator, I have a -1 cubed. What?
I can't do cubing in my head. Like with 1, it's fine.
Oh, wait,
With 1, it's fine.
But like,
No calculator.
Try to do it without a calculator.
you give like if there's like bigger numbers.
Come on, we can, we're a little out of practice.
Can we maybe like give us a minute? I haven't started.
Okay, go ahead. I'll give you a minute. Don't call it out. Don't call it out just yet. Don't call it out. I can, here, I'll walk around and see. Yes.
I forgot how to do this with cases.
Check that. Yes. What happened? Okay. It's okay. What did you guys see? Yes. Hold on. Okay, be careful.
Have you done all the steps or no?
You don't have to show all the steps.
Because I got told last
But
year I
that's-
had to.
That's good.
I'm definitely doing this.
Okay, let me pause because a couple of people, don't forget, this is a -1 squared. Not a negative, and then 1 squared. So you should get 1 minus 3 times 16 times a half. Negative 1 plus 2. Okay. So
What's 3 times?
now, one of the things I did not go over, but you learned commutative property for multiplication, meaning you can multiply, right, 16 times a half or 1/2 times 16. You can multiply, right, as long as these are all multiplication, I can multiply them in different orders. So I can just look at this as 1 minus, and then half of 16 is 8 times 3,
20.
24. So I have 1. Do you see what I did there?
That's genius.
So do you see why I've changed to 0.5 to a half?
Yeah, so then 3 times, are we?
So I did 16. It doesn't matter what order. If it's all multiplication right next to each other, do the half of 16 and then multiply it by 3. So you get 1 minus 24. And the denominator, negative 1, remember, a negative to an even power is going to end up being positive. Negative to an odd power is going to end up being negative. Right? And then that's just going to be negative. Oh, okay.
What is square?
Sorry, for the calculator, it needs to be.
The TI Inspire. Yeah.
I'm almost.
Okay, if you made a mistake, did you catch it when I went through the solution? Great.
Not a calculator, that's the thing with these things.
I know, but this is what I'm trying to get you, and I'm going to teach you some of those shortcuts. Yes, some of them you might already know. It's just with fractions, right? That's the other thing. I'm not trying to scare you. I'm just trying to be honest that there are more fractions in Algebra 2 pre-calculus. And so we're going to do baby steps. We're going to get used to them again. We haven't done them in a while, but they are there. Okay. The formula. So we have a formula. F equals 9/5 C plus 32 represents the conversion of temperature from Celsius to Fahrenheit. What is the Fahrenheit equivalent of 40 degrees Celsius? So, okay. So this is the key. They gave us 40 degrees and they told us that that was the value of C. So I want to figure out what it is in Fahrenheit. So 9/5, okay. Okay, so when we have, now if it was a fraction multiplied by a fraction, you multiply numerators, multiply denominators, and simplify, okay? However, this is 9/5. I would not multiply 9 times 40, right? I would think of this as being over 1. 5 goes into 40 8 times. So now I have 72 plus 32, which gives us 104. So now I'm just going to write this out. So it's 104 degrees Fahrenheit, just so I put those symbols with it. Funny story, we had a thermometer that was somehow stuck in Celsius for like a year, and we couldn't figure out how to get it out of. I know the formula, so I just used the formula to convert it to Fahrenheit. I know approximately, but I wanted to have exact, in case one of us had a fever or something. We got it fixed.
Did you do it in your head, or will you do it with?
No, I
with
did
a
it.
calculator? See.
My friend from England baked cookies at my house, and he forgot that the oven was
Oh,
in
it was in Fahrenheit.
So he set it to 180 degrees, and we got like flat cookies.
It's not gonna bake very well at that temperature. This is true. That's funny. Yeah, I don't know. Listen, I know we're all used to Fahrenheit and we're used to feet and inches and miles, but the metric system just makes so much more sense with the base 10. But it's okay. We're fine. We're not changing miles to kilometers anytime soon. Okay, the other lesson I wanted to go over were properties of real numbers. Again, I know we didn't really do any of this. You probably didn't do anything last year. I don't know how much detail maybe you did in middle school, but let's go through. So you may have heard the term real number. When we talk about a real number, it's basically anything that you can place on a number line. Right? Picture a number line. So pi. I know pi is not exact, but could you find where pi would be located on a number line?
Yeah.
Yeah. Or square root of 2, I could plug that into my calculator and you get approximately 1.4. Could you find where square root of 2 could go?
Wait, but it's not any number?
So there are something that are not real numbers that we will learn later on.
Like I, right?
Like I, yes, there's imaginary numbers, okay? So for right now, for purposes of this class and everything probably you learned prior, we were only ever working with real numbers. Geometry, we only work with real numbers. Meaning you could have square roots, you could have fractions, you could have decimals, you could have whole numbers, you can have negative numbers, as long as when you plugged it back in you didn't get a negative angle measure or something like that. So those are all real numbers. Real numbers, we use a capital R. You might also use like a R with an extra line in it. I used to use it in algebra. Don't worry about it for now. That double-lined R just means all real numbers. Remember, like, I don't know if you learned in algebra, you'd have all real numbers or no solution would sometimes come up. This is an abbreviation for all real numbers. When we're working with the abbreviation, we're just going to use R, just a plain R. Okay, now, the rest of these are all subcategories. Rational numbers. They can be expressed as a ratio. You could do A over B. So that can be 2/3. It can be, here's, right, -7/8. It can be 4, because could you put 4 over 1? Yeah, so it can be a number like that. Or -2. Can you put -2 over 1? Yes. What about 0? 0 over 1? Yeah.
Isn't that just
Okay.
zero?
So basically, rational numbers are anything that you can write as a fraction, and that would include also terminating decimals or repeating decimals,
What's it terminating this?
like 1.5.
Okay.
Oops, that's a sorry, kind of. Let me just. So it includes, sorry if I'm blocking you just tell me.
Irrationals are repeating, right?
Irrational is a square root, like square root of 2 is an irrational. Anything that doesn't terminate pi.
Yeah, it doesn't terminate.
So those are not rational numbers. And if somebody says, well, what if I put pi over 1? No, that doesn't count, okay? So you have to be able to express it. Like pi is not a rational number. Square root of 2 is not a rational number. There's no fraction that I can express. And when I say fraction, the fraction has to consist, you have to be able to write it as an integer over an integer, which we didn't get to. Right. So I could say like 0.125, because I know that I can also write that as 1/8. That's equivalent to 1/8. All right. So I could do 0.75. I could do 0.4. I can do 1.00000000002. As long as it has an end, then it can be a rational number. And for rational numbers, it looks a little weird, we use a Q. So Q for rationals. Now remember, you see how this diagram is? It's like the real numbers is the big box. And then they get smaller and smaller. These are subcategories. Over here, on the right side, these are irrational numbers. So let me just take a moment. Let me do irrational numbers. Irrational, here, these cannot be represented by a ratio of integers that are decimals. So basically, square root of 2. I'm just going to write some examples. Pi, square root of 8. So I know I can simplify square root of 8 to 2 root 2, but it still has a radical in it. Okay. Yeah, Z.
So something that would be a rational number could be something like 1/3 as a decimal, because that can be simplified like to 1/3 or whatever. Like it's the same.
Yeah. So because 1/3 is 0.333333 repeating, right? So if I showed you 0.3 repeating, a repeating decimal can be written as a fraction.
So it's like 2/3. Does that count? Because I know on calculators sometimes it's 666.
Yeah, 0.66666. That would be repeating. So that would be also rational. Okay, so rational numbers, we're good. You can make it into a fraction. Irrationals, you can't. All right. Now, under rational numbers here, these are your subcategories. So your integers, which we should have heard of, that's Z. These include negative numbers, positive numbers. I'm going to throw in here also 0. 0 is part of the integers. Think of positive and negative whole numbers, but you'll see whole numbers is right underneath that. Whole numbers.
So what's the difference between whole numbers and
Integers can have negative numbers. Whole numbers are only positive. So let me just put in here. These are only positive.
Would 8 also be an integer? Or 8 also be a whole?
Yeah. Integers, I'm going to say and 0. So whole numbers are only positive.
That simplified to a whole number, that's like an actual number.
What's that? I'm sorry.
Can it also be a square root that simplifies to a whole number?
Yes. So do you see here? It has some examples. 296, 0. Square root of 36. Square root of 36 is equal to 6.
So they can
So-
belong, sorry, they can belong to multiple different,
They can go.
belong to multiple different ones.
Oh, absolutely.
Okay.
Absolutely. In fact, the last one are the natural numbers. So natural numbers are only positive integers. So basically not including 0. So that's the last one. So if it's a natural number, that means it's also a whole number, also an integer, also a rational. Sorry, I almost pointed to irrational. And it's obviously a real number.
Wait, so whole numbers, like, I'm just confused about the difference between the whole numbers and natural numbers.
The only difference is you can't have 0 for natural numbers. Okay, so name all the sets of excuse me, I just said one of them. All the sets of numbers to which each number belongs. So we're going to start with R, because they're all real numbers. Yes?
Okay, so for whole, you have the square root of 36, which would just be 6. Why couldn't you put that at natural, because it's technically...
It is. It's technically both.
Okay.
That's just another example. See?
So something like square root of 36 could be a natural.
Yes, yes. Here's what kind of start from the top. They're all real numbers. And then go with this. Is it a rational number? Can you write this as a ratio? Can I put this over 1? Yeah. So it's rational, so I'm going to put Q. If you want to write out the word, you're totally welcome to. I like abbreviations, so I'm going to use the abbreviation that's associated. Okay. So if it's rational, it can't be irrational, so I'm going to skip that one.
Is it natural only positive too?
These two are both positives, yeah.
Then it could be
So can it be an integer?
Yeah.
Yep. So I'm going to put I. Whole number?
No, it's Z.
No, because what did I say up here? Only positives for whole numbers and natural numbers.
integer says
It's
Z.
just Z, yes.
Oh, why did I meant to put Z, sorry. Good catch. Okay, next one. Square root of 49 is 7. If it's a natural number, it's going to be all of these except for irrational. So it's going to be real, rational, integer, whole number, natural number.
Miss Basic.
Uh-huh.
So can is like an irrational number? Like, is that like considered real?
Say that again? Yes, irrational is considered a real number.
Okay, gotcha.
So yeah, this next one, square root of 95.
Like, be working with non-real numbers?
Yes. Yes, we will. Chapter 4. I know. All right, negative 7/8. Okay, so this one's what? Rational and?
Just rational.
Just rational.
Rational. Rational. So we're gonna, I know Q is a weird abbreviation for rational, but we can't use R because R is for the real numbers. And it can be, again, if it's rational, then we're gonna skip the irrational. Can't be any of these, right?
No.
You can't have fractions with integers, whole numbers, or natural numbers. Okay, Z.
Sorry, just a quick
That's
one.
fine. We got time. We got 3 minutes.
Integers have to be full numbers, and then wholes have to be full numbers that aren't negative.
Yes. Yes. So these last 3 can't have decimals or fractions in them. All right. So these 2, so hopefully I tried to summarize these, but the integers are the ones, right? Integers, and then you have like these are subcategories of integers as well, but rational numbers are integers plus all of your repeating and what did I say? Oh, terminating decimals.
And the only difference between whole and natural is 0, right? Whole has 0.
Correct. Whole numbers have 0.